question. You had a question.
I figured it out while y'all were talking.
Okay, good. This is one of the sections that I spend a lot of time on because a lot of you have had hang-ups with algebra before, and it's not that bad. Just like fractions, it's not that bad if you're presented algebra in a decent way. All right, now there is two. Did I turn that on?
He's got to bring his blanket.
Yeah. There's two objectives or two things about algebra that you need to know. Actually, there's three things about algebra. One, it undoes mathematics. You know how subtraction undoes addition and addition undoes subtraction? Well, algebra undoes mathematics. Two, the main objective of algebra. This has a star beside it, meaning, and it's got a red cloud around it. Now, with a star beside it and a red cloud beside it, that might be telling y'all that it's what?
Important.
Mm-hmm. I'm going to just write it in red. The main goal, your main objective of algebra is to get the variable, which is the letter, by what? Itself. That's the main objective of algebra. Once you do that, you have done what you need to do. And the third thing is that you do number two by using the law of equality. What is the law of equality? Well, let's say that Jody and Susie are on a seesaw. Now, I said this one time, and a student that's not from around here told me that I was calling that the wrong thing. It's not a seesaw, it's a teeter-totter. Something like that. You just want to take a bat and just beat the crap out of it. I mean, I hate to be like that, but everybody knows what that is. It's a freaking seesaw, okay? Anyway, if you take Jody and tell Jody to get on the other side and Susie to get on the other side, it still works. You ever had somebody tell you that you have to put the variable on one side of the equal sign? You don't have to. You can put Jody on one side and you can put Susie on the other. Doesn't matter where you put the variable. It's one thing. What if Jody gains 5 pounds? Well, women don't gain weight, so Susie is going to have to go pick up a rock, and that rock is going to have to what? Weigh 5 pounds. Okay? Whatever Jody does, Susie's got to do. Whatever Susie does, Jody's got to do. Why? Because they have to stay equal. And that's the theory of equality. So if Jody throws his 5-pound book bag off, subtract 5 pounds, then what does Susie have to do? She has to throw that away. Whatever Susie does, Jody has to do. Whatever Jody does, Susie has to do. Okay? And these are the 3 things that you got to remember about algebra. Now, most of you know how to do the basic stuff. Most of you know, let's say with addition. X plus 4 is equal to 8. And you say to yourself, well, we got to get the variable by itself, so we got to get rid of adding 4. And how do you get rid of adding 4? And if Jody subtracts it, Susie's got to subtract it. And you get x is equal to 4. And most of you know how to do the one-step algebra. We'll go through and do each one, and hopefully it'll knock your cobwebs loose. Subtraction. X minus 3 is equal to 7. You got to get the x by itself. Well, there's no other x's. I love the people that go, oh, you got to subtract 7. Your x is on this side. Okay, here's your x. This does not even exist to you. This is where your eyeballs should fall. How do you get that x by itself? You got to get rid of a negative 3 by, and if Susie adds 3 pounds, Jody's got to add 3 pounds. So you get x equal 10. And hopefully that knocks some of the cobwebs loose. Multiplication. 3 times x is equal to 21. Well, again, the 21 does not exist to you because you're focused on what? The x. How do you get rid of multiplying by 3? Jody divides by 3. Susie's got to divide by 3. And x is equal to what? 7. Division. X over 3 is equal to 8. Again, you don't look at the 8 because that doesn't register to you. You look here. How do you get rid of dividing by 3? And if you multiply by 3 on one side, you got to multiply by 3 on the other. Well, Hubert, I can do all of those. Well, then why do people have problems with algebra? The reason people have problems with algebra is because of the next screen. I'll go over a few things. 1. Distributive law. 2. Whenever you use the distributive law, usually what's left? What's next? Combine like terms. CLT. 4. Fractions and decimals. Huh?
You went 1, 2, 4.
Smart aleck. 4. Multi-step. That's why people can't do algebra, is because of these 4 things. I take these guys and I take these and then I integrate some of these things and y'all's head explodes. That's what happens. So what we're going to do, I've already taken care of this. I've already taken care of the fractions. We took care of that before, but we're going to visit it again. Common denominator. So let's take a look at some things. Let's take a look at the distributive law. Before we go into distributive law, anybody ever worked with concrete before?
Yep.
Okay. Let's say you live in an environmentally crazy place where you want to put up a mailbox, but you can't put up the mailbox because you have to dig a hole. And in Florida, you're not allowed to dig holes, so you have to put it in you have to do some kind of a concrete thing and bolt it down on the sidewalk with concrete. Okay, because you can't dig.
Sinkholes?
Yeah, no, just it might kill some kind of bug or something. So anyway, yeah. So you make this 3 foot by 3 foot by 1 foot, and you put your pole in here, and you pour the concrete in, and while you're pouring the concrete in, you lose your ring. Okay? Now, most women would know it right after they lost it. But some men, they don't, 2 or 3 weeks later, where's my ring? So, there's your ring right in here. Now, what's going to happen with that concrete after 24 hours?
It's going to get hard.
It cures. Okay? The water dries out, and you're left with a big A piece of concrete. And how's the only way to get to that ring?
Break it out.
Take a BA hammer and maybe a chisel and bust it up. So you got 3 things here. You've got a hammer, which is your tool, and you've got your block of concrete, and you've got your objective. Right? Your objective is to get the ring out.
Yeah.
Where's your objective?
The X is your objective.
The X is our objective. So that's our what? That's our ring. And it's inside of what?
Cement block.
And how do we bust up the cement block? With a what?
Big A hammer.
A hammer. So you got to take that hammer and bust up that block. And that's called the distributive law. I guarantee you, I'll bet $100 bill nobody's ever told you how to do this like this. Because this is Hubert. This is Hubertism. Okay? This is the way I taught myself the distributive law. So 2x plus what?
3.
6 is equal to 4. Now, your main objective, put your little man right here. Your main objective is to get the what? The variable. But I can't get the variable because what's in the way? 6. So how do you undo a positive 6?
Negative.
And if Jody does it, Susie's got to do it. Susie, not Sally. 2x. Susie and Jody aren't very well-respected people. All right, 2x is equal to negative what? Divided by 2. And x is equal to... And what do you do with x is equal to negative 1 to check it? Plug it back in. What's negative 1 plus 3?
Negative 2.
How about positive 2? And 2 times 2, 4 is equal to 4. It balances. And that's how you use distributive law.
And why is that a positive when you the 3?
Negative 1, you owe $1.
Okay.
You have $3.
Okay. All right.
You have 2. 2 times 2 is 4. All right, so there y'all do. Let's do 1. How about 3 times 2x minus 4 is equal to 17. All right, y'all do that. What's 3 times 2x? And 3 times negative 4? The little man is standing here, and he reaches out to get the variable. He can't get it because the negative 12 is in the way. How do you get rid of a negative 12? And if Jody adds 12, Susie's got to add 12. And how do you get rid of multiplying by 6? Now, what's hard about this? It's not hard. But we're going to learn it step by step. And then we're going to put everything together. Now, that is reducible. No, 29, but 39 is reducible. 29 is not. I think it is. I don't care about that. If you do all that, we'll be good. Now that's the distributive law. Let's do one more, just so I can discourage you. Why am I giving you this one? Because of what? This guy right here. Does it affect things?
Yes.
Yes, it does. Just think of it as a bigger hammer or a smaller hammer, depending on what you want to compare it to. That negative does what to everything in the parentheses? Changes the sign. So that's going to be 8x plus what? Is equal to 3. Little man's right here. Can't reach the x because of the 4. How do you get rid of a positive 4? And if Jody does it, if Susie does it, then what? I have to be equal opportunity here. And what's 3 minus 4? You have $3, you owe $4. And then divide by 8. X is equal to negative 1/8. And you can do these all day long. That's the distributive law. Now, after the distributive law, usually when you use the distributive law, the next thing that you do is combine like terms. Now, they usually follow each other in steps. Okay, but what I'm going to do first, before we do both of them together, I'm going to do combining like terms before we do distributive law and combining like terms. So we're not going to worry about this right now. We're just going to combine like terms first. So I'm going to put 2x plus 3 plus 5x minus 2 is equal to 4. Now, the first thing you realize here is this is a cluster. It's a mess, right? When you see this, the first thing you think is, oh no, I don't know if I can do this. There's a lot of stuff up there. Okay, if there's a lot of stuff and a problem, the first thing you should do is what? Clean it up. It's just like when you walk into your house. I do this all the time. When I walk in my front door, I look at the den, and I usually don't do anything until I straighten the den up because it looks at, especially for my Sunday night before I take my son back to his mother's, we usually have party night. So we have movies, pizza, and anyway, the den is don't have like food in it, but he just doesn't care on Sunday night. So his blankets and his shoes, his shorts. So when I go home today, I'll look at that den, and I'll put my keys down and I'll just start cleaning it up. Because what? It drives me bananas. Okay? So when you go into a room like that, some of y'all just push everything out of the way. I'm not talking to y'all. I'm talking to the people. What do you do? Oh my gosh, I gotta clean this up. And that's what that is. I gotta clean this up. So read from left to right, and I'll take my handy dandy blue marker, and I'm gonna put a square around this guy. Is there any more X terms? Right here. So I put a square around that one. And then I go through and I put a circle around this one. And I put a circle around this one. Because what am I doing? I'm going through and I'm picking out like terms. 2x plus 5x is 7x. And as soon as I do that, I cancel it out. And 3 minus 2 is 1 is equal to 4.
Oh, that's easy.
Yep.
But don't
Little
we
man.
still want to get X by itself?
That's always the objective.
Okay.
So we reach out. We can't get to the X because of the 1. How do you get rid of a positive 1? And if Susie does it, so does Jody. 7x is equal to 3. And x is equal to what? 3 over 7. Somebody's out there right now wanting to punch out their algebra teacher in junior high school. All right, let's do a nerd. Okay, do that. If you can't do it and you stall, just consider yourself a failure. No coughing in class. You owe $2, you have $6.
84.
You have $4. 7 minus 2. How you get rid of a positive 5?
Subtract 4 from
How about subtract 5? 4x is equal to negative 9. X is equal to negative 9/4. All right, let's do a nerder. Now, before I do the next problem, I want to go back here. I want to add a number 4. Always try to keep variable what? Anybody want to fill this out? Always try to keep variable positive. Now that's going to be very important for another section we're going to go over in this unit. Okay? Unit 2 is going to be inequalities. This is important if you'd like to just remember one law instead of 3 laws. Okay, now I'm going to have people say, well, that ain't the way I learned to do it. I learned to oh, shut up, I'm not talking to you. Okay? I'm talking to people that want to learn and do it without having to memorize 5 steps, and they only have to memorize 1 step. Okay? I'm not part of that group of teachers that tried to fill you up with a bunch of rules. I'm trying to cut rules. All right? I don't like rules. I just go against the grain. No, I'm just kidding. So, I'm going to give you a problem. And I'm going to show you what I mean. So here we go. Negative 5x plus 2 minus 11x plus 4 equals 2x plus 3x minus 7. Okay, now the first thing you want to do is clean up everything. Okay, just clean up the left side and clean up the right side. Don't start moving anything. Just clean up one side and clean up the other side. I'm going to make this a triangle. And this a triangle. Well, and this is circle. And this is square. And this is square. And this is square. You owe $5. You owe $11. You owe $16. 2 plus 4. 2x plus 3x. Now, let's take a break here. Let's say that I hire you on my farm. I want you to work on my farm. And your job, you only have one job, and that's to feed those dang horses that I bought. Okay? Because I don't want to fool with them. Anyway, that's supposed to be a barn door, but anyway. Oh, whatever. Anyway, the only thing you're supposed to do is feed those dang horses. So, I tell you that there's feed in the barn, and you go out there and the feed is out. There's I got a whole area, this little room right here, and all it's got is pallets, and it's got 3 pallets on it, and it's got feed on the pallets. Okay? And there is a 55-gallon drum that you could put feed into, and there is a 5-gallon bucket that you can put feed into. What will 99% of you pick to put the feed into?
The smaller one.
Smaller bucket. There's always one person in the group that goes against the grain, and they try to pick up that 55-gallon drum half full of feed, and they can't do it. So 99% of y'all are always going to pick the what? Smallest bucket. 1, because it's easy, and 2, we're just lazy. Okay? And 3, you can't pick up a 55-gallon bucket with a quarter of it full of feed, much less half or full. So, okay, 55 gallons up to about right here. Okay, so I just want to make sure y'all realize that, because usually there's somebody, the guy that goes 25 seconds to Panama City, he usually can pick up 4 of those. Okay, now I've got a choice. I can move the 5x, or I can move the 16x, the negative 16x. Well, what about the 6 and the 7? Do we care about the 6 and the 7? No. All we care about is the variable. I always move the smallest what? Bucket. There's your smallest bucket. Always move the smallest bucket. Now this is where you get those people that were taught by the idiots. Sorry. The teachers, oh, well, you'll have to put the variable on the left-hand side. You were taught by an idiot. Because that's the same thing. You take your kids out to the park or wherever, and they got a seesaw. And let's say you take your kids to Anderson Park, Lindley Park. And you take your kids down there, and you got a kid named Gertrude and a guy named Wally. Okay, you got 2 kids. Wally, you say, okay, you sit on the side that's toward the faces toward post office. And Gertrude, you sit on the side that faces against where the post office is. Well, let's say you take your kids down to Ivor State Park. And you say, and Wally and Gertrude, they run out to the seesaw. And they get on opposite sides. And you have a connection. Why? Because Wally is supposed to sit on the one closest to the post office, and Gertrude is supposed to sit away from the post office. How sensible is that? When you go out to get on the seesaw,
it don't matter.
It don't matter.
It don't
So
matter.
anybody telling you that you had to put the variables on the left-hand side, they were telling you that you can't tell your kids they have to stay on the same side of the seesaw until they get in the grade. They have to stay on one side of the seesaw.
It's like pick your battles.
Yeah, exactly. Exactly. So it doesn't matter. Now, why do I tell you to keep the variable positive? If I tell you to keep the variable positive, then you won't have to worry about the 2 or 3 extra laws with the inequalities that you'll forget on the test because you're having a timed test. So just take my word for it. Keep them positive. So I'm going to take this. How do you get rid of a negative 16x? That gives us 6 is equal. What's 5 plus 21? I'm sorry. What's 5 plus 16? 21x. Now, we can't get rid of this x because we've got a negative 7. How do you get rid of a negative 7? You add 7. And divide by 21. And that's your answer. X is equal to 13 over 21. Now, if you chose to do it the other way, then that's going to make the x what? Negative. And when we get to inequalities, there's going to be 2 rules that you have to remember. One is you have to divide through by negative. And 2, if you have an inequality and you divide through by negative, you've got to remember to what with the inequality? You've got to learn to flip it. And what are you going to forget on the test? 1, you're going to forget to divide through by negative. And 2, you're going to forget to flip the inequality because you're rushed because of time. So just keep the variable positive. Just do what you would naturally do on a farm. Pick the smallest bucket. That's what you do 99% of the time. If somebody gives you a job, okay, I'm going to go out, I want you to paint my house. So you're going to go out and you're going to paint, you're going to try to paint it all in one day? No. Most people paint a section at a time. Okay? So, that takes care of the distributive law and combining like terms. Now let's put them together so I can discourage you even more. 2 times x minus 3x plus 6 is equal to 2 times x minus 3. Now, you can combine first, then distribute, or you can distribute, then combine. I don't care. I like to combine first. If there's something in the parentheses, I like to combine that first. So, 1x minus 3x is in the parentheses, and it is combining like terms. So, let's do that first. So, that's going to be 2